In this video, we're talking about how to find the inverse of a function and then to sketch the graph of the inverse. And in this particular problem, we've been given the function f of x is equal to the square root of -1 minus x. So let's go ahead before we do anything else and just sketch this graph. We'll do that by plotting points. So let's look at what the value of this graph is when x is equal to 0. So if we plug in x equals 0, we're going to get -1 minus 0, which is -1. That would leave us with the square root of -1, which is undefined in terms of real numbers. We can only define it in terms of imaginary numbers. So that's not on the real part of the graph, so we know the function is not defined where x is equal to 0. What if we take x equal to +1? Well, we'd get -1 minus 1, that would be -2. We'd still end up with the square root of -2. We can't take the square root of a negative number, so that's also not in the domain of the function. What if we take instead a negative number like -1? Well, there we'd have -1 minus a -1, or -1 plus 1, which would give us 0. So if we say x is -1, then we get the square root of 0, or just 0. So we can say that the point -1, 0, and if we go ahead and plot that, -1, 0, that this point is on our graph. Since we want values we can easily find the square root of, what if we take x equals -5? Well, in that case, we'd have -1 minus a -5, or -1 plus 5. -1 plus 5 is a +4, and the square root of +4 is 2. So we can say that we have the point 1, 2, 3, 4, -5, +2, that exists on our function f of x. So then if we connect these 2 points, and if we were to sketch the rest of this graph, what we would see is that we have a function that looks something roughly like this. So this is going to be our function then. We'll call it f of x. Now the inverse of a function we write like this. We say f to the -1 of x. That's what the notation looks like. But it doesn't mean that we're going to take this right-hand side here and raise it to the power of -1. This just means the inverse of f of x. And the inverse of a function is the reflection of that function over the line y equals x. So this dotted line that we've drawn here is the line y equals x. That'll of course always be the same. The inverse of a function is whatever we get when we reflect the original function over that line. So we can do this graphically if we were just to reflect this function over the line. What you could do is take each point on the original graph and reflect it over the line by drawing a line that's perpendicular to y equals x that runs through this point. So for example, this point here at -1, 0, if we drew a line that was perpendicular to y equals x and ran through this line, it would look something like this, and we would see that the reflection of this point over the line y equals x is this point right here, 0, -1. That's just reflecting this particular point. But if we reflected all the other points on the graph and we reflected the entire curve over the line, we would see that this point, -5, 2, becomes the point 2, -5, and we could go ahead and plot that here, and then we could graph the inverse function, and it would look something like this. And this would be the reflection of the original function over the line y equals x. So that's the graph of the inverse, and we would call it f -1 of x, the inverse function. But how do we find the equation that represents this function? Well, here's how we're going to do it. The first thing we're going to do is we're going to start with the original function, f of x, and we're going to replace f of x with y. So instead of writing f of x, we're going to write y. So we're going to say y is equal to the square root of -1 minus x. Then what we want to do, if we can, is solve this equation for x. So in order to solve for x, we're going to square both sides. So instead of y, we'll get y squared. And when we square the square root, those two things will cancel, and we'll end up with -1 minus x. Then we want to add 1 to both sides, so we're going to get y squared plus 1 is equal to -x. And then we want to multiply both sides by -1 in order to solve for x. So what we end up with then is x is equal to negative quantity y squared plus 1. Now we've solved this equation for x. The reason we did that is because at this point, our next step in finding the inverse function, we want to switch the x and y variables. So literally, where we have x, we're going to put y instead. So this x is going to become y instead. And then where we have y, it's going to become x instead. So we're going to say y is equal to negative x squared plus 1. Then we just want to replace y with this inverse notation, f -1 of x. So instead of saying y is equal to negative quantity x squared plus 1, we're going to say f negative 1 of x is equal to negative quantity x squared plus 1, and this then is the equation for the inverse function. And if you were to graph this, what you would see is you would get this graph here that we sketched for the inverse function, which we found earlier just by reflecting the original function over the line y equals x. But if you need to find the equation of the inverse function, you always follow those steps. So you replace f of x in the original function with y, then you solve this equation for x, which we did here, then you swap the variables. You replace x with y and y with x. Now you have an equation automatically solved for y in terms of x. Then you replace that y with this inverse notation f negative 1 of x, and you now have the equation of the inverse function. So that's how you find the inverse of a function and sketch its graph.